In this unit we're going to look at how to divide two complex numbers. Now, division of complex numbers is rather more complicated than addition, subtraction and multiplication. And division of complex numbers relies on two very important principles. The first is that when you take a complex number and multiply by its complex conjugate, you get a real number. The second important principle is that when you have a fraction, you can multiply the numerator and the denominator, that's the number on the top and the number on the bottom of the fraction, by the same value and not change the value of a fraction. So for example, if you start with a fraction a half and you multiply the top and bottom by 5, you get 5/10, and the value of 5/10 is the same as the value of a half. And that's really going to be very important when we come to being able to work out how to divide one complex number by another. So let's look at an example. So we're going to take the complex number 4 plus 7i, and we're going to divide it by the complex number 1 minus 3i. Now remember that a division is the same thing as a fraction. So this complex number divided by this one, we can just write as one complex number over another complex number. So now we have a fraction. What we can say is that we won't change the value of this fraction if we multiply the numerator and the denominator by the same value. Now I'm going to choose to multiply the denominator by 1 plus 3i. 1 plus 3i is the complex conjugate of 1 minus 3i. And we choose this complex conjugate so that when we do the multiplication, what's in the denominator will turn out to be a real number. So if we're multiplying the denominator by 1 plus 3i, we've got to multiply the numerator by 1 plus 3i. So that way we've multiplied the numerator and the denominator by the same value, so we haven't changed the value of the answer. So let's now multiply these two fractions together. We multiply out the two terms in the numerator, we multiply out the two terms in the denominator. So we get 4 times 1 is 4, 4 times 3i is 12i, 7i times 1 is 7i, plus 7i times plus 3i is plus 21i squared. So that's multiplied the two terms in the numerator. Now we multiply the two terms in the denominator. So we get 1 times 1, 1 times plus 3i, minus 3i times 1, and minus 3i times plus 3i gives us minus 9i squared. Right, let's tidy this up. 21i squared is 21 times minus 1, so that's minus 21. So we've got 4 minus 21 is minus 17. 12i plus 7i is 19i. So we've got plus 19i. And then in the denominator, I squared is minus 1. So we've got minus 9 times minus 1 is plus 9. 1 plus 9 is 10. And 3i minus 3i is nothing. So the imaginary terms disappear. So we've ended up with a real denominator. So we could leave our answer like this, or we could split it up as minus 17 over 10 plus 19 over 10i, which if we want we could write as minus 1.7 plus 1.9i. So that's our answer. When we divide 4 plus 7i by 1 minus 3i, we get minus 1.7 plus 1.9i. Now let's do another example to illustrate the principles again. Here are two more complex numbers, 2 minus 5i and minus 4 plus 3i. So we're going to divide the first one by the second one, and we write those as a fraction. 2 minus 5i over minus 4 plus 3i. Now the way to do it is to multiply, we want to multiply the denominator by its complex conjugate, which is minus 4 minus 3i. And because we're multiplying the denominator by this value, we must multiply the numerator by this value as well. Now we multiply out the numerator and the denominator. So we have 2 times minus 4 is minus 8. 2 times minus 3i is minus 6i. Minus 5i times minus 4 is plus 20i. And minus 5i times minus 3i is plus 15i squared. And then in the denominator, we have minus 4 times minus 4, which is 16. Minus 4 times minus 3i, which is plus 12i. Plus 3i times minus 4, which is minus 12i. And plus 3i times minus 3i, which is minus 9i squared. And now we tidy these up. 15i squared is minus 15. So we've got minus 8 minus 15 is minus 23. Minus 6i plus 20i is plus 14i. So that's the numerator simplified. And then the denominator, we've got minus 9i squared, so that's plus 9. So we've got 16 plus 9 is 25. And 12i minus 12i, that disappears, leaving us with a real denominator, which is what we wanted. So we can write that as minus 23 over 25 plus 14 over 25i, which we could also write as minus 0.92 plus 0.56i. And so that's the result of doing this division. Now, in the next unit, we'll look at something called the Argand diagram, which is a way of graphically representing complex numbers.